Hi you guys, Mrs. Sladen here. So these videos are going to be what helps you guys on your lessons for 1.7 and 1.8, which will be Thursday and Friday. So very important to take some notes on this lesson so that you're ready for the example problems that we're going to do in class. So today's objective is for you guys to be able to demonstrate the ability to apply rules of exponents, or properties sometimes is what they're called. And basically we're going to look at 5 properties today. These are going to be the ones that you're going to need to memorize, because as you start looking at problems, you're going to need to know how to attack those problems based on these unique properties, okay? So we're going to go through, first of all, just a little bit of a review. First of all, I just want to remind you that anytime we have a to the b power, this is referred to as our base, and this is referred to as our exponent. Okay, our base is our number or variable that's going to be multiplied repeatedly, okay, as we expand and get into more of the detailed exponents. Then our exponent is really just the value that's going to specify how many times we're going to multiply that base times itself, okay? So if we have a to the third, obviously it's like writing a times a times a, okay? So just a quick review right there. And then we're going to get into these rules of exponents. So as a reminder, okay, and you guys have seen this before hopefully, if you have two bases that are the same and you're multiplying, all you're going to do is add those exponents. So for example, if we have a to the second power times a to the fifth power, we're going to add the 2 plus the 5 to get us a to the seventh power, okay? And if I was to expand that out, okay, draw 2 a's here times 5 a's here, obviously we'd be able to count and you would see that there were indeed 7 a's, okay? For the next rule, we're going to have, if you were dividing, okay, the same bases with different powers, okay, you're going to actually end up with a subtraction of your exponents. So that base right there is going to stay the same, and then you're going to subtract the b minus the c, okay? So, for example, if we had a to the seventh divided by a to the second, and that basically looks like this, okay? So another way of writing that. So either way, if you see it that way or that way, it's the same thing, but you end up with a to the 7 minus 2, which equals a to the fifth, okay? Now, to test this, again, you could draw out 7 a's dividing by 2 a's, okay? And those would cancel out, okay? And then you'd be left with 1, 2, 3, 4, 5 a's, okay? For our third property, okay, now this one gets a little tricky, and this tends to stump a lot of people because this is very different from this, okay? You notice this has parentheses, and I'm going to work this one out for you guys just to show you, okay? So in our example, if we have parentheses and we have a power going to a power, we're going to multiply the exponents instead, okay? So don't confuse this one with this one, okay? This property tells us that if we have a base with an exponent in parentheses, again, we multiply the exponent. So for example, if we had a to the second power 5 times, okay, really, this is what we have, okay, a to the second 5 times, and then again, if I take my exponents, I have 2, 4, 6, 8, 10, and that gives me a to the 10th, okay? Now let's look at this if we were actually using a number here, okay? So what we're going to do is let's take our number, actually we're going to use 2. 2 to the second, okay? Because this is an example of what this would look like if we were working this out, okay? Now here, okay, I would have 2 to the second and then to the fifth power, okay? So I'm going to multiply my exponents, and I end up with 2 to the 10th power, okay? So that would be my answer there, okay? And again, the distinguishing characteristic of this one is going to be the parentheses, okay? So one more example, if I had a, b to the c power, okay? Now I've got two bases in here, and I'm going to end up with a to the c power, b to the c power, okay? And we'll get into this a little bit later. But again, this just gives you guys an idea of what you're going to do once you have those parentheses and how that changes which property we're going to apply. Okay? Now for our fourth property, we are taking our negative exponent, okay? And we're actually, this is going to be a term you're going to become familiar with is with inverse, okay? Or you can look at it as we're going to put this in fractional form, okay? And really all we're doing is putting 1 over our number, but we're changing because we're moving this to the denominator. We're taking that negative and we're making that be positive in the denominator, okay? So, for example, if we had a to the negative fourth, okay, it actually becomes 1 over a to the fourth. So all we did was take this information, we moved it down into the denominator, we made our exponent positive, and we put the 1 in the numerator, okay? So for our example here, if we had, let's say, 5 to the negative fourth power, my first step would be to notice that this is negative and I don't want that negative exponent. So I'm immediately going to put it 1 over 5 to the fourth power, which really is 1 over 625. Okay? Now, for our last rule, this is that zero exponent rule. And what I want you to remember, anything to the 0 power is always 1, okay? A to the 0 power is 1, okay? And then guess what? Pi to the 0 power is 1, okay? 9,999,999 to the 0 power, okay? Even though it's this huge number, is also just 1, okay? So those are your 5 properties that we're going to be working with, okay? And we will be able to go over some more example problems and hopefully clarify some more information as we get into just some different problems. And again, we're just going to need to look at these. You're going to need to memorize these so that you remember exactly which ones we want to apply given the problem that it's asking for. So thanks, guys. See you in class.